switch is rated for 15 amps should not be used in 20 amp circuits. The switch becomes a potential point of failure if the current exceeds its rating. Excessive heating could occur, which could lead to a fire or electrical shock. The National Electrical Code prohibits the use of switches rated for less than the circuit ampacity. A 15 amp switch is designed to safely handle up to 15 amps of current. Exceeding this rating could damage the switch or compromise its integrity. There is an exception. In some cases, a 15 amp switch may be used in a 20 amp circuit if it is specifically rated for such use by the manufacturer. These switches are typically marked with an appropriate designation, such as 15 amps, 20 amps resistive. Here are the consequences of using an undersized switch. Firstly, there is a fire hazard due to overheating. Secondly, electrical shock or arcing may occur. Thirdly, it will reduce the life expectancy of the switch. Fourthly, circuit interruption or nuisance tripping of the breaker may occur. It is always best to use switches that are rated for the circuit ampacity or higher. For a 20 amp circuit, use switches rated for 20 amps or 25 amps. It's crucial to understand the reasons why using appropriately rated electrical components is essential for safety and code compliance. Let's delve deeper into the specifics. Considering the safety implications, a switch with a lower amperage rating than the circuit it's connected to is a significant fire hazard. When the current exceeds the switch's capacity, the internal components begin to overheat. This heat can melt the insulation around the wires, leading to short circuits, sparks, and potentially a fire. Electrical shock is another serious risk. If the switch fails due to overheating, it could expose live electrical parts, posing a danger to anyone who comes into contact with it. Furthermore, arcing, which is the discharge of electricity across a gap, can occur within the switch. This is not only a fire hazard, but also a source of electromagnetic interference that can damage sensitive electronic equipment. Code compliance is not merely a suggestion but a legal requirement. The National Electrical Code, or NEC, is a set of standards designed to ensure electrical safety. By using components that meet or exceed the NEC requirements, electrical installations are safer and more reliable. Violating these codes can result in fines, legal liabilities, and, most importantly, increased risk of injury or property damage. Now consider the current handling capacity. Electrical components are designed with specific current ratings to ensure they can safely operate under expected loads. A 15 amp switch is built to handle a maximum of 15 amps of current without overheating or failing. When a 20 amp circuit pushes more current through this switch than it is designed to handle, it creates a situation where failure is likely. Over time, this can cause the switch to degrade and eventually fail, which can disrupt the circuit and potentially create a hazardous situation. While there are exceptions to every rule, they must be approached with caution. Some 15 amp switches are specifically designed and rated by the manufacturer to handle the demands of a 20 amp resistive load. These switches are typically marked with designations like 15 amps, 20 amps resistive to indicate their special capabilities. However, it is essential to verify the manufacturer's specifications and ensure that the switch is suitable for the intended application. Using a switch that is not properly rated, even with a resistive designation, can still lead to problems if the load is inductive or contains motors, which draw significantly higher currents when starting. Here is a detailed breakdown of the consequences of using an undersized switch. Firstly, a fire hazard due to overheating. When the current exceeds the switch's rating, the excess energy is dissipated as heat. This heat can build up rapidly, especially within the confined space of the switch, causing the plastic components to melt and potentially ignite nearby flammable materials. Secondly, electrical shock or arcing. As the switch deteriorates due to overheating, it becomes more likely to fail. This failure can expose live electrical parts, creating a risk of electrical shock. Arcing, the uncontrolled discharge of electricity, can also occur, which is not only a shock hazard but also a potential ignition source. Thirdly, reduce life expectancy of the switch. Even if the switch does not immediately fail, consistently operating it beyond its rated capacity will significantly shorten its lifespan. the internal components will degrade more rapidly, leading to premature failure and the need for frequent replacements. Fourthly, circuit interruption or nuisance tripping of the breaker. An overloaded switch can cause the circuit breaker to trip, interrupting the power supply. While this is a safety feature designed to prevent more serious problems, such as a fire, it can be inconvenient and disruptive. Frequent tripping of the breaker is a sign that something is wrong and should be investigated immediately. It's always best to use switches that are rated for the circuit ampacity or higher. For a 20 amp circuit, using switches rated for 20 amps or 25 amps is the safest and most reliable approach. This ensures that the switch can handle the maximum current that the circuit is designed to carry without overheating or failing. Oversizing the switch slightly, by using a 25 amp rated switch on a 20 amp circuit, provides an extra margin of safety and can prolong the life of the switch. When selecting switches for a particular application, it is essential to consider the type of load that the switch will be controlling. Resistive loads, such as incandescent lights, draw a constant amount of current. Inductive loads, such as motors and transformers, draw a much higher current when they are first turned on. This inrush current can be several times the normal operating current. Therefore, switches used with inductive loads must be rated to handle this inrush current. Failure to do so can lead to premature failure of the switch. In addition to the amperage rating, it is also important to consider the voltage rating of the switch. The switch must be rated for the voltage of the circuit in which it will be used. Using a switch with an inadequate voltage rating can lead to insulation breakdown and electrical shock hazards. The type of switch is also an important consideration. There are many different types of switches available, each designed for specific applications. Single-pole switches are used to control a single circuit from a single location. Three-way switches are used to control a single circuit from two locations. Four-way switches are used in conjunction with three-way switches to control a single circuit from three or more locations. Dimmer switches are used to control the brightness of lights. Each type of switch has its own specific characteristics and limitations, so it is important to choose the right switch for the application. Here is a summary of key points to keep in mind. Firstly, never use a 15 amp switch on a 20 amp circuit unless it is specifically rated for such use by the manufacturer. Secondly, always check the manufacturer's specifications and ensure that the switch is suitable for the intended application. Thirdly, consider the type of load that the switch will be controlling and choose the switch that is rated to handle the expected current. Fourthly, ensure that the switch is rated for the voltage of the circuit in which it will be used. Fifthly, choose the right type of switch for the application. Following these guidelines will help ensure the safety and reliability of electrical installations. A more in-depth look into the National Electrical Code, or NEC, and its relevance to switch ratings and circuit ampacity is important. The NEC is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect the latest technologies and best practices. The NEC provides specific guidelines for the selection and use of electrical components, including switches. One of the most important rules is that the ampacity of a circuit cannot be less than the rating of any of the components in that circuit. This means that if a circuit is rated for 20 amps, all of the components in that circuit, including the switches, must be rated for at least 20 amps. There are some exceptions to this rule, but they are very specific and must be carefully followed. For example, a 15 amp switch may be used in a 20 amp circuit if it is specifically rated for such use by the manufacturer. However, the manufacturer's instructions must be followed carefully, and the switch must be protected by a 15 amp circuit breaker. The NEC also provides guidelines for the derriting of electrical components. Derriting is the process of reducing the ampacity of a component to account for factors such as ambient temperature and the number of conductors in a conduit. For example, if a switch is installed in a hot environment, its ampacity may need to be derrited to prevent it from overheating. The NEC also provides guidelines for the installation of electrical components. These guidelines are designed to ensure that the components are installed in a safe and reliable manner. For example, the NEC requires that all electrical connections be made inside of approved enclosures and that all wiring be properly supported and protected. In addition to the NEC, there may be local electrical codes that apply to electrical installations. These codes may be more stringent than the NEC, so it is important to check with the local authorities to determine the applicable requirements. Adhering to these codes is crucial for safety and compliance. Proper selection of electrical components plays a significant role in maintaining the integrity of an electrical system. Selecting components with the correct ratings and characteristics is essential for preventing overloads, short circuits, and other electrical hazards. Overloads occur when a circuit is carrying more current than it is designed to handle. This can cause the wiring to overheat, which can lead to a fire. Short circuits occur when there is an unintended connection between two conductors. This can cause a large amount of current to flow through the circuit, which can damage the wiring and equipment. Properly sized components can help prevent these problems by providing adequate capacity and protection. Regular maintenance and inspection of electrical systems are also important for ensuring their safety and reliability. Over time, electrical components can deteriorate due to factors such as heat, moisture, and vibration. This can lead to reduced performance, increased risk of failure, and potential safety hazards. Regular maintenance, such as tightening connections, cleaning components, and replacing worn parts, can help extend the life of electrical systems and prevent problems. Regular inspections can also help identify potential problems before they become serious. These inspections should be performed by qualified electricians who are trained to identify and address electrical hazards. This includes inspecting wiring, switches, outlets, and other electrical components for signs of damage or deterioration. It also involves testing the electrical system to ensure that it is operating properly and safely. By following these guidelines, electrical systems can be kept in good working order and potential hazards can be minimized. Remember that electrical work should always be performed by qualified professionals who are trained to handle electrical systems safely and effectively. Attempting to perform electrical work without proper training and experience can be dangerous and can lead to serious injury or property damage. If you are not comfortable working with electricity, it is always best to call a qualified electrician to handle the job. Electrical safety is paramount and should never be compromised.